Hello there, Paulus here. I am creating a video for you to use to finish up class notes for the scientific method. These are the notes that we began in class, but some people write faster than others. And for those of you that were maybe absent or just simply couldn't keep up, use this video to fill in the blanks. I also will be providing some explanation along with the slides. If hearing my voice while you're trying to read and write down things or type things, you are more than welcome to turn the volume down, but you will be losing a little bit of explanation. Okay, first things first. Class notes like this have to be done in Cornell Notes style. Okay, so pull out a piece of paper, please. And what I want you to do is, if you want to type these, that's totally okay. So open up a document, open up a Google Doc, a blank Google document, or open up Microsoft Word or any application where you can type. In the upper right-hand corner, please put your name. On the first line, if you wouldn't mind writing the scientific method or the SM class notes, or write CLSNTS for class notes. Give them a title, put your name in the upper right-hand corner. Then draw a line down the center of the page. On Google Classroom, I will have a template for you to use to take class notes. If you want to type them, that's totally fine. I might be going a little bit too fast in this video, so feel free to pause it and then finish up your writing or finish up your typing, and then restart the video. That way you can keep up with the pace. Okay, I'm not going to make this video tremendously long. It makes it harder for me to upload. Makes it more difficult for me. So I'm going to be cruising through the slides at a relatively fast pace. But please feel free to pause the video at any time, finish writing or finish your typing, and then restart the video when you are ready. Okay? All right, so again, line down the center of the page, or please use the template that I have provided for you if you're typing it. Make sure you number all of the questions. Okay, so I want to see, I don't know what this ends up at, maybe 17, 18, 19. The way that I'm going to do it in Google Classroom is I'm going to just simply check all your pages. I'm going to count up all your numbers, and if you've got 1 through 19, okay, and you weren't too lazy, you didn't abbreviate too much, you didn't shorten your sentences too much, you're going to get full credit. If you do not number them, and I have to count them up myself, you will automatically lose a half a point. If you do not have your name on them in the upper right-hand corner, you will automatically lose a half a point. Maybe it doesn't sound like that much, but this is probably going to be worth 3 points. And if you forget both of those things, your A plus just went to a D. So please always remember to put your name in the upper right-hand corner, and always remember, at least on class notes or things that are numbered like movie facts, number each item to make it easy for me to count and give you the points. Okay, all right, here we go. Scientific method, you can abbreviate that every time after this as capital S, capital M. So anytime you see scientific method from here on out, you can put capital S, capital M. But it's a process that we use to find answers to questions. You do not have to be a scientist to use a scientific method. It is just a process, an organized manner of finding answers to questions. Okay? When you're an adult, regardless of whether or not you're a scientist, if you have a problem and you follow a certain set of procedures in order to get to an answer, you will save yourself a lot of money, and you will be victimized way less than people who are like, oh, okay, it's going to cost me that much? All right, fine, whatever. Okay, cool. Let's do it. Who do I write the check out to? So it's important to have an understanding of how to find answers to questions in an organized manner. Is there more than one scientific method? Of course there is. Some have more steps, but they all begin with a problem or a question, and they all use observation and an organized method for an experiment. An experiment may not be mixing chemicals together. An experiment may just simply be figuring out what happened based on an observation. Okay? So it looks like in this image, we have an experiment where we're trying to figure out maybe what mix of chemicals will give the most explosive reaction for a rocket. Not really sure what they're doing in the middle. I see slime, so maybe they're determining what chemicals or household items can be used to make slime. Again, some of you guys may still be writing for number 2. Pause now, because I'm about to jump ahead. All right, hypothesis. Hypothesis is an educated guess based on observations and previous knowledge. Basically, the book's definition is a statement, something you say about an observation. By the way, wearing my Rio basketball jersey today to remind you or inform you that I am the teacher on campus with the most school spirit. I'm a huge sports fan, and I even like the non-sexy sports, tennis, water polo. Of course, I like basketball, football, and baseball, and the big sports. But I like all the sports, and I support all the sports. Maybe don't go to all the sporting events, but I at least talk about them. And of course, we're in the number 21 to support my big man on the Sixers, Joel Embiid. The game should be ending right around now. Game number 2 against the evil Celtics. Big Sixer fan. You can see my Dr. J poster in the background. I've been a fan since the early 80s. And, of course, the Dr. J, Larry Bird rivalry. My brother was a Celtics fan at that time. He's a Kings fan now. Was heated. There's some great rivalries back between those teams. Not expecting to beat the Celtics in 7 games. They're better. We lost our all-star Ben Simmons, but it is what it is. All right, data. It's the information gathered during an experiment. If we're talking about quantitative data is measured. You use a tool, some sort of measurement. It's going to have a unit, inches, pounds, degrees. If it's qualitative data is less specific. You don't have to write this down. You'll learn about qualitative and quantitative data later. But qualitative data is like larger, smaller, hotter, colder, heavier, lighter. It still tells you something, but it's not specific. And usually that has a follow-up question. It's like, how much hotter? How much heavier? Steps of the scientific method. There are different scientific methods, but basically you have a problem, okay? You identify a problem. You form a hypothesis. So you're going to have some sort of an observation before you come up with your hypothesis. You're going to create the experiment, which is basically the procedure. You're going to come up with the steps necessary to run that experiment. You're going to do the experiment. You're going to analyze the data or analyze your results. And then you're going to modify the experiment. So let's say your results don't come out the way that you thought, okay? A couple things could happen. Maybe you did the experiment wrong. So before you modify the experiment, I would go back and do it again just to make sure you didn't make any mistakes. And if you continually get this wrong information, you might want to go back and change the experiment. That would be modifying the experiment and redoing it. Or if you actually, your results match what your hypothesis is, you communicate your results. For the purposes of this biology class, you're going to be writing a lab report, and you're going to be, excuse me, I'm really tired. I'm battling through this. I haven't slept over the last couple nights. It will be writing a lab report and sharing those results in a conclusion. Okay, and we'll get to not in this, but we'll get to the parts of a lab report later time. Again, some of you guys are still writing down the answer for number 5. Remember, all the questions on the left, all the answers on the right. If you are writing on number 5 right now, pause the video. I'm about to jump ahead. Okay, what's the name of the process used to find answers to questions? Take a look back at number 1. I probably should have those notes out so I can point you guys in the right direction. My bad. All right. Hopefully you've had an opportunity to look up that answer. The correct answer is the scientific method. This one thing that all scientific methods have in common. I believe that was number 2. Of course, while I'm being recorded in a video, I'm going to be struggling to find my copy of them. It's a good thing we haven't done too much. There they are. Sweet. Yeah, take a look at number 2. So they all start with a problem or a question, and they all use observation and an organized method for an experiment. That would be a procedure. They all use an organized procedure. Information gathering during an experiment is called what? Or information gathered. Is that called a hypothesis, or is that called data? And if you're not sure, you might take a look at number 4 in your notes. That is data. Okay. Some of you guys are just going to fast forward past this. I would not recommend doing that. The more you practice with your notes, the better you're going to do when it comes to the test. Every extra 30 seconds you spend studying, learning the information now will be 30 seconds or a minute later that you're not going to have to study because you've already done some work on learning it. Okay. Obviously, if you know what the answers are right away, rock on. You're a rock star. You're probably going to get an A in my class. But if you don't know what the answer is, please take an opportunity to go back and look it up if you're not sure what it is. Okay, identifying the problem. It's what you want to know or what you want explained. You write a question. All right, second part of the scientific method is to come up with a hypothesis. What do you think will happen? Make a prediction. Okay. And this is why observation is so important. Is because if you're just guessing what's going to happen, you might be right. You probably will be wrong. So I would make some observations so your hypothesis is closer to what will actually occur. Okay. All right, and then you create the experiment. You develop a procedure. A procedure is numbered. A procedure should be so detailed that somebody not taking biology, somebody with no scientific knowledge whatsoever, if you give them all the materials, everything they were going to need for the experiment, they should be able to read that, follow the experiment, and get the exact same results you get. Your procedure should be that detailed. For the most part, in the labs in this class, well, maybe next semester. Hopefully we're back in the classroom. It's safe for us all to be around each other on the classroom next semester. But for the most part, for labs, I am going to be doing the lab myself and giving you what the procedure is. Or maybe I'll be recording a video and you'll have to actually watch what I'm doing and write the procedure based on what you see me doing. Okay. Usually I give you the steps necessary. But when you're writing a lab report, you're going to have to transfer that information over to your lab report. Okay, I'm about to jump ahead, so pause the video if I'm going too fast. Okay, then you perform the experiment. That's the fun part. Unfortunately, because everybody's at home, you're not going to get to experience a lot of that fun until we get back in the classroom again, hopefully next semester. I will, for the most part, be doing the labs, recording videos for you, or maybe I'll be doing the labs live in a Zoom meeting. But unfortunately, you can't have everybody together, and I'm not sending my equipment out to you guys. So this is the best we can do. Follow steps in the procedure, record data and observations during the experiment. And as you can see, those look like some middle school kids, probably 6th graders, 7th graders, getting together, talking about their results, looking for trends, seeing if the results that one team got match the results that another team got. This is where you decide whether or not you get to communicate your results, in your case, write a lab report, or if you need to go back and do the experiment again, and then again, and then again, and then again. And if it still comes out wrong, you might decide whether or not you want to modify the experiment. Again, I'm about to bump ahead. So if you're still writing down either 9 or 10, or both. Might want to pause the video. By the way, if you're keeping up with this pace, you write really fast. I just really hope I can read it. If you're a decent typer, if you have decent typing speed and you are typing your notes, you're probably keeping up just fine. You're probably tapping your finger. Go ahead, Paulus. Show me the next slide. Getting bored with this. Please go ahead. And some of you guys have no idea what the heck I'm even saying because you turn the volume down and you're listening to your own music, which is just fine. But again, you're going to be missing some of the explanations, some of the examples I'm giving. And you're probably wondering what the heck I'm doing when I'm doing crazy stuff like this. I don't know. All right, moving on. All right. When I normally show these notes in class, I've got a drawer next to my TA and my TA desk filled with candy and called a candy question. Normally, I would say, I got a candy question. That's a question to get you candy. If you know the answer to the candy question, you're ready to answer the candy question, and then everybody gets all excited because they like candy. What is the name of that character from the famous Muppets? That character's name is Beaker, and Beaker gets into all sorts of trouble. As you can see, he lit something on fire, and you can see his facial expression. He is flipping out. So Beaker, it was hilarious. I really enjoyed the Muppets when I was young. You guys might not even have any idea what I'm talking about. Go to YouTube, find some Muppet episodes. They're pretty funny. Jim Henson was amazing. He was the creator of the Muppets. All right, if the data is inaccurate, you're going to modify the experiment and do it again. Or usually, if it's an expensive experiment, you're going to go try it a couple more times to see if you might have made a mistake. Teenagers, you're definitely going to try it again because teenagers make mistakes. Oh no, we're going again. Oh, I'm really sorry, and I still got a basketball game to watch tonight. We'll see how that goes. Modify the experiment, rewrite the procedure to address mistakes in the first one. Here's what you don't do, though. You do not write a procedure that will get you the results that you want. You don't change the experiment to match it with your hypothesis, okay? If that's what you're doing, that's cheating in science. What you do is you go modify your hypothesis, okay? You don't change the experiment to match your results. You change your hypothesis to match the experiment, okay? Sorry about that. Maybe went a little too fast. Go ahead and pause if you're still writing down number 12. Okay, if the original data is okay, you communicate the results. Bam, it looks like I have really no idea what this graphic is from, but at face value, it looks like females are smarter than males. My wife certainly thinks so. Okay, communicate the results. So obviously you can see there's some Asian gentlemen there with a slideshow sharing their findings in some sort of an experiment. So for you guys, you're going to be writing a conclusion. If it's a professional scientist, and especially if the science is groundbreaking and really important, they're probably going to be writing an article and asking that gets put in a professional scientific journal. Of course, if it's really important stuff, they will probably speak in front of hundreds or thousands of other scientists in the future. For your purposes, though, if your data is decent, you're going to be simply writing your conclusion and including that data in your conclusion. All right, I'm about to jump ahead. We're nearly finished here. We are finished here. So if you're still writing down number 14, please pause the video. Okay, after you identify the problem, what do you do next? If you're not sure about that, so I got a question. So what do I do next? You're going to make an observation, and then you're going to make a statement about that observation, and take a look back at number 7 if you really have no idea what I'm talking about here. Yeah, you're going to form a hypothesis. When analyzing data, if you determine that the data is inaccurate, what must you do? And if you're not sure, you might want to take a look back at number 11. And remember, if it's a really expensive, involved procedure, you're probably going to go back and do it a couple more times just to make sure you didn't make any mistakes while doing the experiment. But let's assume you've already done that. You would modify the experiment and do it again. Last one, you can communicate results and form a conclusion only when the blank is found to be accurate, when the procedure is accurate or when the data is accurate. And if you're not too sure, you might want to take a look at number 13. You're right, it's data. But, I mean, honestly, if the data is accurate, the procedure and the experiment itself was probably written accurately, so technically the answer would be both. But for the purposes of these notes, data. Okay, so you have just finished the notes. Okay, a couple things to remind you of before you upload this to Google Classroom is that it's got to be in Cornell note style. Got to have questions on the left, got to have answers on the right. If you didn't do that, turn it in, but you are not going to get full credit. And everybody should get full credit on the class notes. Reading notes, maybe, maybe not, depending on how many you do and how you do them. They also should be numbered. Okay, so you should have number 1 through 14. Okay, 1 through 14. And remember, if you are typing these and you are using the template that I provided for you, the font should be Arial, A-R-I-A-L, and the font size should be 14. Okay? You're going to save these if you typed them up. You are going to upload them into Google Classroom. If you wrote these, you need to take a good quality image with a cell phone, okay, or with a tablet or an iPad. Make sure it's well lit. You've got light shining on it, or you use the flash. You should be able to expand that and read every single word in that image, because in some cases, I'm going to be spot checking your notes to make sure that you weren't being lazy or that you were writing the correct notes. I need to be able to read them. And then you're going to upload those images to Google Classroom. I hope you enjoyed this video. I hope the extra information that I provided helped make you understand it a little bit more. And go Sixers. All right, we'll see you guys in the next Zoom meeting. Where's my... And signing off.